Continuing on with our Unit 2 review. On vacation, you purchased a painting from a local artist for $2,000. Since the purchase, the artist has gained national attention and the painting you purchased is now worth $5,000. Find the absolute and relative change in the value of the painting. Okay, so I'm going to remember that absolute is a number and relative change is a percent. Okay. So for the absolute, it's the compared value minus the reference value, which is 5,000 minus 2,000, which is 3,000. For the relative change, there are two formulas you can use. You can either use that it's the absolute change divided by the reference value. Since we have that, so that's going to be 3,000 divided by 2,000, which gives me 1.5 or 150%. Remember, change to percent. Okay. Okay, scientific notation. Again, make sure you know how to use your calculator for this or know how to do it on your own. If I want to write each of these numbers in scientific notation, I know I'm going to start out with something times 10 to some power. Okay. Now, how do I know what number goes in front? I need to move the decimal from here to here, so this is going to be 1.27. Then I'm going to look at how many places I move the decimal. First of all, I know this is a number smaller than 1, which means my exponent is going to be negative. And I moved it 1, 2, 3, 4, 5, 6, 7, 8 places. Whoops, is that right? 1, 2, 3, 4, 5, 6, 7, 8. So 10 to the negative 8. Okay. All right, for my next one, I know it's going to be something times 10. Since this is a big number, that's going to be positive. I know my decimal needs to go right here. So it's going to be 7.306. And let's see, my decimal went from here. I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9 places to the 9th. Okay, if I'm given scientific notation and I want to write it as a number, I know I'm going to write this. The numeric part is going to be 377. 10 to the 5th means it's going to be a number larger than 1, which means I'm going to move it to the right. So I'm going to take this and move it 1, 2, 3, 4, 5 places to the right. Fill in any holes with zeros. And the answer is 377,000. Okay. If I start with a very small number, I know I'm going to have to start out with 0 point something. And my 907 is going to be over here. And I'm going to take this decimal and move it here. It has to go 6 places. So 1, 2, 3, 4, 5, 6. So I fill in with 1, 2, 3, 4, 5 zeros. Okay, If I'm asked to perform operations, the thing I want to remember here again is how to do this on my calculator. And the key to putting things in parentheses. You're going to want this for your unit conversions as well as just your general operations. Okay, so I'm going to put mine in scientific notation mode, so my answer will come back in scientific notation, not that it, but I can do it either way. And I'm going to put things in parentheses. So I have 1.2 times 10 to the 7th times 4.5 times 10 to the -3. And make sure you're using the negative sign rather than the subtraction sign. And what do I get? I end up in scientific notation with 5.4 times 10 to the 4th. Remember that E4 means 5.4 times 10 to that exponent. Now, if I was asked to write this as a number, again, you could probably do it in your calculator. If I just switch back to normal mode, do the whole thing again, and I get 54,000. Read your instructions. What do they want you to do? This is the one I want you to remember. I think this is the one that we're probably going to use most frequently, and that the parentheses are the most important. You have to take that top part and divide it by the bottom part in parentheses. Okay, now I'm in scientific notation mode, so I'm just going to leave it like that. 3.1 times 10 to the 3rd, close my parentheses, divided by 4.5 times 10 to the -2, close my parentheses. Oh, it's in normal mode. Okay, so that's 6, 6, 8, 8, 8, 8, and we'll call it 0.9. If I want to put that in scientific notation mode, I can write that as 6.9 times 10 to the 4th. I know I have to move this 1, 2, 3, 4 places to the left. I just rounded it to 6.9. Okay. How many liters of oil would you need to burn to provide the energy used by the average American home for a month? And it says assume 30 days in a month, so there's must be something I'm going to have to do with that. So I'm going to have to look at my conversion chart, which I have lost. Here we go. So how many liters of oil? That's what it wants to know. So I want to end in liters of oil. That's where I want to end. Okay. Well, what am I starting with? I am starting with a month. So I'm going to start with 1 month. And I put it over 1. Okay. All right. So let's see what I've got here. All right. Well, I've got something about 1 liter of oil and the energy that it is released. And I have something about electricity used by a home daily. Okay, so if I want to use that, I'm going to have to convert month to days. So this first one, I'm going to do month to days. So I know 1 month is equal to 30 days. Okay. Okay, so with that, I got rid of my months. Now I need to get rid of my days. and I'm going to have to convert it to energy. So the next one I'm going to look at is going to convert days to joules. Okay, so I know 1 day in the average American home is 5 times 10 to the 7th joules. Okay, so the days are gone. And finally, I need to convert the joules to liters of oil. So I've got to get rid of the joules, and I'm going to have liters of oil in the numerator. So I know 1 liter of oil is 1.2 times 10 to the 7th. And that got rid of the joules. So all I'm left with are my liters of oil. So now I'm just going to do the math. So everything in the numerator, I have 30 times 5 times 10 to the 7th divided by 1.2 times 10 to the 7th in the denominator. Okay, then I just use my calculator. 30 times 5 times 10 to the 7th divided by 1.2 times 10 to the 7th, and I get 125. So it would take 125 liters of oil to provide the average American home with energy for a month. Okay. Okie dokie. Find the rate of inflation between 2003 and 2019. Okay. That means I need CPIs. So the CPI in 2003 from my table is 184. And the CPI in 2019 is 255.7. So from here, all I have to do is find out which is the compared value and which is the reference value. Well, if we want to find the rate between these two, then this is going to be my reference, and this is going to be my compared. So now it's just the relative change formula. So it's going to be the CPI 2019 minus the CPI 2003 divided by the CPI 2003. 255.7 minus 184 divided by 184, which gives us 0.39 or 39%. All right, in 2000, a particular TV cost $300. What would be the equivalent cost in 2020? Okay, well, once again, I'm going to have to find my CPIs. So the CPI in 2000, and I'm just taking this from the chart, is 172.2, and the CPI in 2020 is going to be 258.8. Okay. So the cost in 2020 is going to be 300, I'm going to put it over 1, times the CPI in 2020 divided by the CPI in 2000. That gives me 300 over 1 times 258.8 divided by 172.2, and when I round that, that becomes $450.87. Okay, in 2010, a teacher's salary was $35,000. In 2017, the same teacher earned $41,000. Did the teacher's earnings keep up with inflation? Well, clearly they got raises, but did they end up just breaking even, or did they make more than the cost of living, or did they make less? Okay. All right, so we're going to have to use the relative change formula. And we're going to have to do it we're going to use the relative change formula. And we're going to do it twice. We're going to do it for the salaries, and then we're going to do the CPIs to find the inflation. Okay. Well, let's see. This is going to be our compared value, and this will be our reference value for our salaries. So we're going to take 41,000 minus 35,000 divided by 35,000. Okay. Compared value minus reference value divided by reference value. And when you do that, you get 0.171 or 17.1%. Okay, so the salary increased 17.1%. Now, let's look at what inflation did. So the CPI in 2010 was 218.1. The CPI in 2017 is 245.1. We're going to use the same formula, only using CPIs. So we're going to do 245.1, the compared value, minus the reference value, 218.1, divided by the reference value is 218.1, and you get 0.124, which is 12.4%. So, did it keep up with inflation? Yes. Earnings exceeded inflation. Okay. Now, lastly, we're going to talk about false positives and false negatives. Okay. So here we have a chart, and this is a test to determine if somebody has lupus. Okay. So, how the table works. This down here is our total participants. Okay. This is the total with lupus, and these are not going to be consistent with what we've done in class. So this is total lupus. This is the total no lupus. This is our total positive. This is our total negative. Okay. All right. This is our true positive. Have lupus, tested positive. These are our false positives. They tested positive, but they don't have lupus. This is our false negative. They have lupus, but the test didn't say that. And finally, our true negative. They don't have lupus, and the test showed that they don't have lupus. Okay. All right, so for each of these, what percent of those who test positive actually have lupus? Okay, so we're going to have to find the ratio of those of the total positive and how many of those have lupus. So the true positive. So that's going to be 90 divided by 95, which gives us 0.947 or 94.7%. And again, read your instructions. Did they ask you to round to a certain amount? If not, it's okay. All right, the next we're going to find the ratio, the percent of those who do not have lupus. So 205, how many out of those test positive? Those are our false positives. And when you do that division, you get 0.024 or 2.4%. Okay. Okay, what percent of those tested? Well, that's going to be our total percent. Those tested have lupus and tested negative. So out of everybody, they have lupus and they tested negative. Have lupus and tested negative is going to be 10. And when I do that division, that is 0.033 or 3.3%. Okay. So how accurate is the test? Okay. Well, let's see. What percent of those tested, which is 305, got an accurate result? Okay, well, these are the ones that are accurate. And if you add those up, that's 90 plus 200. So this becomes 290 out of 305, which is 0.951 or 95.1%. Okay. Okay, the end.